Hey guys, I hope you all are doing well. Welcome back to day 5 of Advent of Code. Today we're gonna be doing print Q. So let's start. Satisfied with their search and series, the squadron of scholars suggests subsequent list canon. The stationary stacks of Sub-Basement 17. The North Pole printing department is busier than ever. This close to Christmas, and while the historians continued their search of this historically significant facility, an elf operating a very familiar printer beckons you over. The elf must recognize you because they waste no time explaining that the new sleigh launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed. So you offer your services. Safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation X or Y means that if both page number X and page number Y are to be printed as part of an update, page number X must be printed at some point before page number Y. The elf has for you both the page ordering rules and the pages to produce in each update, but can't figure out whether each update has the page in the right order, okay? So we get these inputs, okay? The first section specifies page ordering rules, 1 per line. First rule 47, vertical bar 53 means that if an update includes both page number 47, then page 47 must be printed at some point before page number 53, okay. The second section specifies the page numbers of each update because most safety manuals are different. The pages needed in the updates are different too, okay. Right, in the above example, the first update is in the right order, okay, because 75, each one of these values maps follows the rules, okay. So, for some reason, the elves also need to know the middle page number of each update being printed, because you are only printing the correctly ordered updates. You will need to find the middle page number of each correctly ordered update. In the above example, the correctly ordered updates are this. Okay, these have page numbers. So guys, what we need to do is parse our puzzle input and then find the middle page number and then add it up, and then we'll get our answer. So let's start coding. First, I'm gonna copy the example input and the puzzle input. So I'm gonna cd into admin of code. Let's create directory for day 5. I'm gonna save the example that we copied. Then I'm gonna copy the puzzle now, the actual puzzle input. And then now guys, I'm gonna be writing the solution in C. I could do it in a different language, but like for example Python, but it's gonna be too simple. So I'm just going to do it in C. So I'm going to include the standard input-output library. I'm going to include the list library that we implemented, guys. So .lib /list.h turn 0. I'm going to include ctype.h. And then, guys, I'm going to read from our input files, our puzzle input files. I'm gonna read from the example.txt first. And I'm gonna say while fscanf mod d or mod d. So we get each numbers that are separated by this vertical bar. And then we're gonna get those integers. And we're gonna do this as long as our match count is equal to 2. So then now guys, we're gonna actually have an array of lists, guys. So I'm gonna create a function called list array. Let's create a structure called typedef struct list array t underscore t, and it's gonna contain a list t pointer of lists, and guys, it's gonna have a list count. So void, I'm gonna have an initialization thing. I don't have to do that now. I'm gonna have a function to append a list to it. So list array t pointer let's say array list, and then it's gonna accept a pointer to a list, guys, and then it's essentially gonna sort in this structure, guys. So we're gonna say if not array list, then we're gonna have a list t pointer new lists equal to null, and then guys, we can just say new lists equal to malloc size of list t. Otherwise we can say new lists equals realloc array list, and then we can say array list count plus 1 times the size of a list t. Then we can say if not new lists, then we just return guys, and then now whenever this allocation succeeds, we can just say array lists new lists at index I at index array list count is gonna be equal to list count plus is gonna be equal to list array, but before we increment the count, guys, we're gonna say new list array list count equal dot new lists list count dot array equals to list array, and dot length equals to list length, guys. And then I'm gonna say array list equals to new lists. I'm gonna have an initialization function, so void array list array init, taking a list array t pointer to array list, and we're just gonna say array list equals to null, array list count equals to null. And then now, guys, we can just say void, we're gonna have a function to destroy or list array. So list array destroy, it's gonna accept a list array t array list. Then, guys, we're gonna say array list count. We're gonna call list array init again. But before we do that, we're gonna need to say iterate through each list. So array list count. Then we're just gonna say list underscore destroy list dot array underscore list. Wait, this should be lists, guys. Lists at index I, and then we can set it to null. Yeah, we can just destroy each one of those, guys. Then we can just say free array lists. And then we're gonna have a function to print out our array of lists in a visual manner, guys. So let's do that. So list array print, this is what it's gonna do. It's just gonna accept this. So now that we have that structure, guys, we can just say have a list array t, let's call it rules, and we're gonna set it equal to, we're gonna initialize it, guys, and then we're gonna have one called updates. And then now, guys, we're gonna say we're gonna have a list here right here called rule, and each time we read a x and y value, we're just gonna say list append rule x, list append rule y, and then, guys, we can say list array underscore append ampersand rules, and then we pass in our rule, guys, as a pointer. Then guys, we can just say list init. We don't even have to do that, guys. So, and then now guys, we can just call list array underscore print our rules, then list array destroy rules. So let's run our code guys and see what we get. So okay, I made a few mistakes. So the first one is line number 12. Okay, this should be 0. Line 17. Alright, now let's recompile. One more issue at line 38. Oh, this should be this. And one more issue. I forgot to pass in the file stream. One more issue at line 55. Oh, this should be a pointer to our rules. Okay. So it compiled, but it didn't print anything. That's because I forgot to increment the count, guys. So now it should work. Okay, so let's ensure that everything is being printed correctly. So let's go into day 5. Let's see if, so you can see guys, we're extracting each number from each page rules. So now we need to parse the page numbers or each updates line by line. So let's do that. We're gonna say right in here guys, we're gonna say char c equals fget c f. We're gonna say if c is equal to a new line, then c is going to be equal to fget c, and we're going to say if not is digit c, then we're just going to break. Otherwise we're just going to say on get c cf. And then guys, I'm gonna parse the page numbers. So I'm gonna have a list T of the page numbers. So let's just call it page numbers. We're gonna say while fscanf mod d equals to 1. There should be a comma after a number, so we're gonna say char c equals fget c f if c is is equal to a new line, then and we're gonna call list append right here, guys. So list underscore append page numbers, and we're gonna place that number in Z. We're gonna append that Z, guys, and then we're gonna say if C is equal to a new line character, then we're gonna say list array append ampersand updates page numbers, which is, this is going to be a pointer again. Then we're just going to say list init page numbers, and we're going to call list array destroy rules at the end. And now, guys, we can say list print update. So let's do a printf updates are new line, and then this is going to be page rules. So we're right here, guys, we're gonna say if not is digit, if C, we're gonna say C equals F get C, F right here. We're gonna say if not is digit C, then let's do it right down below here. Then we're just gonna say list, we're just gonna break, guys, right here. Otherwise we're just gonna say on get CCF. And let's run our program. Made a mistake right here. This should be list array underscore print, and let's run the code. Okay, so now we're getting our updates parsed correctly. Yeah, just like it should. So now, guys, we're gonna actually solve the problem that now that we've parsed everything properly. So I'm going to create a function called bool is update underscore is correct, and it's going to take in a list array T of our rules and the list array T of our update. For update, and it's gonna iterate through each value in that update. So size ti equals to 0, I is less than the update dot count, and we're gonna say actually, guys, we're gonna we're gonna iterate through that. So, guys, we're gonna say for size t, j is equal to 0, j is less than the rules count as well. and we're gonna say if update at index, this is going to be update count -1, if update dot lists at index I dot array yeah, for each updates, guys, we're gonna need to iterate through each of those values. So we're gonna say for size t, j is equal to 0, j is less than the update dot hold on. So we have the update dot lists at index I dot count, and if updates dot lists at index I dot array at index j we're gonna also iterate through our rules. So we're gonna have another function called find is rule match. It's gonna take in our list t, list array t to the rules, or list array to the rules, and it's gonna take in two values. So it's gonna be int A and int B, and we're gonna say if we're gonna iterate through each of our rules. So for size t, I equals 0 is less than update.count I plus plus, if, then we're gonna say for size t, j equals 0, j is less than update.lists index I dot count j plus plus, if update.lists at if rules, this should be rules as well, rules dot list at index I dot array index I is equal to a, that's going to be index j is equal to a. Then, guys, we're gonna say int, we're gonna have a count called integer called match count. Then we're just gonna say match count plus plus. Oh, and we're gonna actually return the index that we found the match. So it's gonna be size t match index. Wait, since each one of our rules, guys, is just consists of two integers, we can just say rules.listIndexI at index 0 is equal to a, then we increment the match count, and if rules.lists at index I dot array index 1 is equal to b, then match count plus plus. Wait, hold on. And rules.listIndexi.arrayIndex1 is equal to b, then we just say we're gonna have a boolean right here called found match. We're gonna let it equal to false, then we're just gonna say found match equals to true, then we just break, then we just return found match. Then now guys, we can just call if is rule match wait, let's not return the indexes yet because we're not finished as yet, so we're just gonna say if is rule underscore match update.lists index I. Now we need to pass in the rules. Then we're gonna say update.lists index I index j. Wait, this should be the count, and right here we should say -1 right here, guys. So update.lists at index j and update.list at index I j plus 1. And if it is a match, guys, then we're just gonna return true. And then now guys, we're gonna have another function called int find underscore number of, let's call it find correct updates. I'm gonna take in a list array t rules list array t updates. It's just gonna take in a list t of that update, guys, so we could just say update dot this actually. Update.count, and then we just say update dot array index I plus 1 right here, -1 up here. That means up here needs to be list T also. Now this array thing is alright. So then now guys, we're gonna say for size ti equals 0, I is less than rules.count I plus. No, I is less than updates.count. We're gonna say if is rule underscore match rules updates updates.lists at index I, guys. Then we're just gonna say printf found correct match colon new line list update is correct, so we can just say rules and then updates dot lists at index I. And we can say list print updates.lists at index I. So let's see what we get. I need to include std bool at line 56. Update.length update.array. Let's run the code, okay, but let's call our find correct update function. Updates takes in our rules and our updates, and let's run our code. It says found correct match 7F547615329. Six, 1, 3. Wait, is this correct? So it found 9747. Then it found 9761532913. Then it found 752913. Okay, so there's a small issue with this, guys, so wait, array index I update. Oh, I see. So I'm gonna say if not is rule match, then just return false, and at the end we just return true. So now, guys, we should get the correct thing. So we should say printf found correct match, and then you can see it's working, guys. So we get those two things, and now we just need to find the total middle page. Let's just return a list T, guys, of the indexes. We're going to return a list array T of the correct update. So correct updates equal to this. And each time we find a correct update, guys, we're going to say array list this means we're gonna have to pass this in as a pointer. So that's gonna be lists underscore array append correct updates list index I, and then we can just return our correct updates. And I'm gonna create another function called void find, just say print total middle pages. So list array T rules, list array T correct, list array T rules, again list array T updates, and then we just call list array T correct updates equals to this thing. And for size Ti equals 0 is less than updates count I plus plus. If update is correct, rules updates, no, not that, no, this should be correct so correct updates should be find correct updates rules updates. And then, guys, we're gonna have an integer. Let's call it total middle pages. Set that to 0. And at the end, we're gonna say printf the total number of middle pages, or mod D, new line, total middle pages, total middle pages plus equal. So we're gonna need to find the middle element, so we're gonna say int find middle page. It's gonna take in a list T to update, and then we're gonna say return update dot length divided by 2 update.array index update.length divided by 2. And then, guys, we're just gonna say total middle pages. We're just gonna call. Don't even. This function is too small, guys. Let's just say total middle pages equals to updates equals to correct updates dot lists index I wait dot correct updates dot lists index I dot count. We divide that by 2, and then this should be correct underscore updates dot array at that particular index. And then let's see what we get for our answer, guys. But we need to call the print total thing. So print underscore total middle pages, yeah, and it takes in our rules and a pointer to our updates. Oh, and when we're finished, we need to just say free correct updates lists, and then you can just say list init correct updates, yeah, list array. Okay, so we made a mistake. This should be correct updates.count. Dot lists index I dot length So it says our total number of middle pages is 143, and that is correct. So let's test it now on our puzzle.txt. And we get this for our answer. Let's try it. And we got that part. So now we have another part, guys. Alright, so let's see. While the elves get to work printing the correct ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to put the pages in the right order. For the above example, here are the 3 incorrect ordered updates and their correct orderings. After taking only the incorrect ordered updates and ordering them correctly, their middle page numbers are 47, 29, 43, blah blah blah. Adding these together produces 123. Wait, is that less than the answer that we got at first? Yeah, it is less. Oh, wait, so for each of the incorrectly ordered updates, so we're supposed to correct the incorrect ones using the rules that they gave us for the page ordering. Okay, find the updates which are not in the correct order. What do you get if you add up the middle numbers after correctly ordering just those updates? Oh, so guys, I'm gonna solve it. So guys, my plan to solve this is for each of the incorrect ones, we're just gonna iterate through each one of the incorrect updates, and then if we're gonna compare each element meanwhile we're iterating to the next element that comes after it. So we're gonna say, is 75 and 47 obeying the rule? So we check our page rules. 75 and 47. Yes, it is obeying the rules. So therefore, guys, we're just gonna say, alright, so I know that this one is incorrect. So we're just gonna say like 75 is 75 and 97 correct? And then we're gonna search. So 75 and 97. Where's that? 75, 97 right here. We're gonna say no because they're out of place. So then we're just gonna swap 75 with 75, and then you see how it's happening right here, guys. So let's start coding. So guys, I'm gonna save the challenge 1 solution. Wait, let me open solve.c. Let's change it back to the puzzle. So just gonna / puzzle txt. And then I'm gonna say mkdir challenge 1. And then I'm gonna create a directory for challenge 2. Copy challenge 1 solve.c into challenge 2. Right, now let's hold on. Let's go into challenge 2. Okay, so I'm gonna have to edit challenge 1 solve.c and challenge 2. Let's go back in there. And we're we're gonna edit its solvex.c as well to point to the folder of our header file. Alright, so we get that thing again, guys. So now we're gonna modify it so that it actually finds that it actually corrects the incorrect things. So here's how I'm gonna do it. So I'm gonna rename this function called find correct updates to find incorrect updates. And then I'm gonna return the incorrect updates. I'm gonna say if not update is correct, then I'm just gonna append that list that is incorrect. And then now, guys, in this middle page thing, I'm just gonna say list correct, list array t. Just gonna make this incorrect update. So incorrect. And I'm gonna create a function, guys, called correct underscore updates. Underscore update. So it's gonna take in a list t, list array t of our rules, and it's gonna take in a list t of the update. Let's make this a pointer because we're gonna need to modify the current update. So we're gonna iterate through each item within our array. So for size ti equals 0, I is less than the update dot length. Since this is a pointer, we can just use the arrow function, the arrow operator, I mean. So we can say if update so this should be update length minus 1. So we're gonna say if update this should be find incorrect updates. So we're gonna say if update dot array at index I if is rule underscore match update dot array I plus 1 then we're just gonna say, guys, we're gonna say if this is false, Then we're just gonna swap our current element. So that's gonna be swap update. We're gonna pass in our rules right here. We're gonna say swap update dot array index I with update dot array index I plus 1. And then guys, we're just gonna call our correct update function. So correct update, and it accepts our rules, then it accepts incorrect update. So we're gonna pass in incorrect update dot lists index I, and this is gonna be a pointer. And because this is a pointer, guys, up here we made a mistake right here, so this should be that. And then now guys, we can say incorrect right here. And then now guys, let's test our solve.c. This should, let's do it on our example. List array append. Incorrect update. Return incorrect updates. Free in correct updates. So now let's run this, and we get 105 for our answer. Is that correct? No, we're supposed to get 123. So let's see what's happening here. Alright, so we corrected our updates. So we should print, let's do a list array print corrected updates or incorrect updates. And we get let's see if it matches this thing that we're supposed to get. So we get 97, 75, then we get 47, then we get 61, 29, 47, 29, 975, 29. Oh, this is 9775. Then we check if 75 equal to 29. This way we say 29 with 47. It is wrong, but it didn't swap. Wait, 29. Yeah, it's supposed to swap right here. Wait, let me think. So we say we have 97, 29, 47, 13. Oh, I think I know what to do, guys, so maybe we should actually do another loop. So it's gonna be and let's see what we get now. Nope. So we get 97, 75, then 29. Wait, hold on. So 29 with 47. That is supposed to be incorrect. Oh, now we get the correct answer, guys. Now let's try it on our puzzle TXT. Get this for our answer. Now let's test it. And we solved the problem, guys. So I'll see you guys tomorrow for day 6. Thank you all for watching. Goodbye.